In today's note, we're going to summarize the transformations of quadratics. So we're going to be looking at a certain form of quadratic functions and looking at how each individual value changes the look. So this is a summary of the investigation that you would have previously done. So when dealing with transformations of quadratics, the key thing that we're looking at, or the key formula, is going to always be our vertex form. So this vertex form, which we've talked about in the last unit when we looked at quadratics, this form is going to be solely for transformations. So there are three different values, the a, h, and k value. These are the values that we are going to be looking at or need to identify when dealing with transformations. So the a value, when the a value is a value or a number that is greater than 1, whether it's positive or negative, if it's greater than 1, that means we have what we call a vertical stretch. So we have a vertical stretch by a factor of whatever the a value has to be or happens to be. So a vertical stretch by a factor of, and we'll just put a blank. So basically this means when we're vertically stretching something, we have a parabola like this. We stretch it vertically, so we pull it up, which what happens is it makes our parabola really skinny. Oh, didn't really change. So it makes it very skinny, something like that. So if you want to also put, you could just put in brackets as well, skinny. When a is between 0 and 1, we have what is called a vertical compression. So this is where we take our parabola and we smush it down or compress it. So if we compress it downwards vertically, pushing it down from the top, we get something that's more spread out. So vertical, and it'd be the same thing by a factor of whatever a happens to be. So vertical compression by a factor. Let me just move this over. By a factor of, again, whatever the a value happens to be. So the factor of blank. Recolor this. Or in other words, we can think of, for lack of a better term, you could say our parabola gets fat, right? It gets really wide. When a is negative, we have what we call a reflection in the x-axis. So basically we have something that's flipped, so now it opens downwards. So basically, in other words, you could call it flipped. So this is basically now where we have our parabola opening down, something like that. When h is positive, so in our brackets, or in our formula, h is in the brackets. So when h is positive, but we have to keep in mind, we're looking, if it's a positive or we're subtracting a positive, in the negative, or in the brackets, it's going to look negative. So we would want to put negative in brackets, just to reassure us that if I do see a negative number in the bracket, it actually means a positive value. And this is a horizontal translation, or you could just say a horizontal shift to the right. When h is negative or positive in the brackets, because if we're subtracting a negative, it actually shows up as a positive. So positive in brackets, it's again a horizontal translation or shift to the left. And our k value, our last value on the outside, if k is positive, we have what we call a vertical translation. or again, shift, and it goes up. So or vertical translation up. So basically we're moving it up and down. And when K is negative, again, just the opposite, vertical translation or vertical shift down. So basically we move our parabola down. So these are the three values that you have to look at when you're dealing with transformations of quadratics, and you're going to use these to kind of figure out how your parabola or how your quadratic has been transformed. But in order to figure out how it's been transformed, we need to know what the base form is. So this is the base form of our function. So we have it in three different ways. We can see the table of values. We can see the function equation, f at x equals x squared. That's your most basic form of a quadratic. And if we were to graph that, we would see this parabola here. I'm going to just write in some of the key points that we want to know. So again, we have our key points here. So we have our vertex at 0, 0. We have our first point at 1, 1. Then we have another point at 2, 4. Then 3, 9. And same thing on the other side. Negative 1 and 1. Negative 2 and 4. Negative 3 and 9. So again, those are our key points. So if you're looking at a graph and you want to know how it's transformed, you can use this. You can also use the vertex. The vertex is a very important point because that's an easy place to tell how it shifted. And usually the first point after it is another way to tell, because the first point lets you know if the A value has changed, right? Because again, remember the step pattern. I'll write this down. Step pattern is 1A, 3A, 5A. Right, so whatever we see as that first step, right, you know, we go over and then up. Whatever that first step up happens to be, remember that's our A value. So that's another easy way to figure out that A value. You might be able to look at it and tell if it's been compressed or stretched, but to figure out by what factor or by what number, you want to find that first step. So let's look at some examples. So example 1, we want to describe what the transformations are based on our main graph f at x equals x squared. So if I look at the first one, the only thing that's actually changed is this A value in front. And there's two parts to this A value. It's a 3, which is greater than 1. So that means we have a vertical stretch by a factor of 3. So that takes care of the 3. Let me just rewrite this and make it a little bit neater. By a factor of 3. And the negative means it is a vertical or a reflection, reflection in the x-axis, or you could just say flipped. Either way is fine. If I look at B, again, kind of want to identify what key things are there. Again, you're looking for that A, H, and K value. So I don't have an A value, or it's 1, which is fine, that doesn't change, but I do have an H and a K value, which I've highlighted. So if you're not sure what these values represent, go back to that last page and just kind of figure out again, okay, if is it the H value, what value is it, and then and see the legend kind of. So we have positive 4. We talked about if we see a positive in the brackets, that means that our H value is actually negative. So that means we have a horizontal translation or a horizontal shift left. So it's left, but it's also specifically 4 units. So we do want to be specific. We're shifting left 4 units. And our -3 at the end, so again, that's the K value, so that means that has to be dealing with a vertical shift or a vertical translation. Again, for the k value, you just take the number as is, so it's negative, which means we move down. So vertical translation down, and it's 3 units. For C, we only have, again, still 2 things to look at. So we have a k value, and we do have an a value that's slightly different. We have that negative there. So we'll start with the negative, keep it simple. Negative just means it's flipped, or that reflection in the x, opening down. And the k value at the end is positive 6. So that means we have a vertical translation or a vertical shift up, because it's positive, 6 units. Or you could just say up 6. For D, we have 3 things to look at here. So we have an A, an H, and a K all there. So again, referring back to the last page, if we forget, the A value tells us the stretch or compression, and then whether it is reflected or flipped. So it's a positive value, so that means there's no reflection. It is between 0 and 1, so that means we have a vertical compression by a factor of 0.25. We have a horizontal shift because we have a H value. So a horizontal shift of, we need the direction. So because we see the negative in the brackets, that's actually a positive value. So that means we have a horizontal shift right in the positive direction. You could say right 3. And our last value, the K, we have a vertical shift up 7 because it's a positive 7. So that's how we kind of look at an equation or of a quadratic function and come up with what the transformations are. Again, based off of this base form here. Right, remember that's your base form at the top. That's what everything refers back to. So in 2, what we're going to be looking at, we're going to be given the transformations, and we have to then come up with what the equation would be. So we're still dealing with a quadratic, so we're still dealing with this base form here. And because we're dealing with a quadratic, we know it has to be in vertex form, which is y or f of x equals ax minus h squared plus k. That's the form we need to use, and then we need to fill in the a, h, and k based on what our transformations are. So if we start off, we have y equals, do we have anything referring to the a value? So there is no reflection, there's no stretch or compression, so the a value just stays the same, which is just always 1. So I could put a 1 there, or leave it as nothing. I don't need to put anything, but I'm just going to put 1 there just to show it. X, and then our h value now. So are we moving it, or are we doing a horizontal translation left or right? We are. So we are moving it left 5 units. So left is in the negative direction. I need to put the opposite into the equation. So I need to see it as plus 5. Right? Because again, when we see the plus in the bracket or in the equation, we should know that that is actually the opposite. So if it's minus and negative, it shows up. So left 5 is minus 5, but in the equation, we see it as positive 5. And then finally, our k value, we are moving it up 3. So that means we just do plus 3 at the end. For B, now we see a reflection in the x-axis. So that means our a value has to be negative. And we do see a vertical stretch by a factor of 2. So that means the a value has to be 2 because we're stretching it. It tells us the factor. There is nothing else. There's no other vertical or horizontal translation. So I can just leave it as x squared. I could put it as x minus 0 squared plus 0, but that just basically reverts to y equals, or f of x equals, negative 2x squared. Just simplified. C, Vertical translation down 4 units, horizontal translation right 2 units, vertical compression by a factor of 0.25, and a reflection in the x-axis. So this one has all 4. So this is as complicated as it would get. So we're going to start off with y equals, we're going to start with our a value. Because there is reflection in the x, that means it needs to be negative. Because there's a vertical compression, that tells us the a value of something other than 1. So it's going to be 0.25 because it's a compression by a factor of 0.25. In our brackets, we do have a horizontal translation right, so that means I need to see a -2 squared, or the opposite. And then vertical translation down 4 units, so that means the k value is -4. And finally for D, vertical translation up 8 units, and a vertical compression by a factor of 0.5. So we have an a value and a k value. So the a value is 0.5. It's still positive because it doesn't say that it's reflected. I have my x value. I'm just going to do x minus 0 because there is no translation left or right. So x minus 0 squared plus 8 because I'm moving it up 8. And I can simplify this to y equals 0.5 times x squared plus 8. So that is the simplified form. So again, the key thing here is just knowing that when we're dealing with transformations of quadratics, we are dealing with the vertex form, y equals a x minus h squared plus k, and then we need to know what the 3 values represent in terms of transformations. Right, again, remember a represents either it compressing or stretching, and whether it's reflected or flipped. The h value is shifting it left or right, and the k value is shifting it up or down. So again, just need to remember those couple things and how they look in the actual equation.